So, hey guys, we're back. With this chapter, for this last chapter, we'll be focusing on how to build a small network. So, yeah, proceed with this chapter summary. Okay, so with this chapter, it has four sections: network design, network security, basic network performance, and network troubleshooting. Start with network design. So, network design. As the word itself. It's all about the design, um, what its topologies, how the small network works, or probably just like the small network like you have at home. So you have the internet, you have the WAN, and you have the LAN. So these are all the connections from a small network, typically a home connection. So the majority of the business or a small network is not very surprising. So mostly majority of networks are small or connections are not that a lot of hosts are connecting or a small network is designed to be very usually simple or number and type of devices included are significantly reduced compared to the larger network. The network topology typically involves a single router and one or more switches. So this is our router, this one. It is connected to internet and connected to a one server with probably five end devices. It is considered a small network. Small host, um, small connection, and very simple. Next is device selection for a small network. So device selection. So of course, the cost is low. Ports are very limited. Speed is quite minimal, expandable, and quite manageable. Uh, the cost is if a switch is or the router is determined by its capacity and features. If you wanted to have a faster or stronger connection, of course you will be spending a lot or giving more for your router. Also, device capacity includes the number and types of ports available at the backplane speed, while in speed and types of ports interfaces, choosing the number and types of ports on a router or switch is critical decision. Newer computers have built-in 1 GB or NICS to 10 GB ports are already included with some workstations and servers. In expandability, networking devices came in both fixed and modular physical configurations. And in operating system features, devices and services like security, quality of service, voice over IP or the VoIP, layer 3 switching, network address translation or the NAT table, dynamic host configuration protocol or the DHCP. So next is the network security. So we're familiar with network security, a lot of threats or probably viruses, attacks that may take or ruin your identity or data. So we have four types of threats: information threat, data loss manipulation, identity theft, and disruption of service. So information theft, as an example, you have a computer breaking or someone's breaking into your computer without your confirmation or your yeah, data loss manipulation. This is a breaking into a computer to destroy or alter a data record. Example, data lost or sending a virus that reformats a computer. So next is identity theft. Identity theft is a form of information theft where personal information is stolen from you. Lastly, disruption of service. This is preventing legitimate users from accessing or denial of service or attacks on servers or the network service or network devices that are links to not to call that reliable sources that may affect your um, data or identity. So yeah, so that there are these are the four uh, types of threats, and the next is the network attacks, types of malware. We have viruses, we have worms, we have Trojan. Mm, in viruses, it is a very common malware that probably all computers have. Like can be ranged to severity from causing mildly annoying effects, damaging or data lost, or a larger spread of viruses to your software or documents. While in worms, computer worms are similar to viruses in that they replicate functional copies or it can cause some type of damage in your data. While in Trojan horses, a Trojan horse is another type of malware named after a wooden horse that the Greeks used to infiltrate Troy. It is a harmful piece of software that looks legitimate. Users are typically tricked into loading and executing in in their in their system. So, unlike the viruses and worms, Trojan horses do not reproduce by infecting other files, but it is much dangerous than the other malwares like the viruses and the worms. And the network attack mitigation. So with this one, we have the backup, upgrade, and patch. So with that backup, upgrade, update, and patch, we are keeping up to date the latest developments, and it can lead to more effective defense against network attacks. So we back up, we upgrade mm, we upgraded the defense against the network attacks or the malware that is newly released, and update and patch the system that is inside your computer. Or the most effective way to mitigate a worm attack is to download security updates like Avast, McAfee, and other security uh, for your malware or attacks from network. Yeah. So next is firewall. So firewall, guys, is used for internets or connection. So we have four firewalls, four types of firewalls. We have Cisco security appliances, server-based firewall, Cisco wireless broadband router, and the personal firewall. The personal firewall is being found inside your computer, where it is the its purpose is to defend the OS itself or the operating system. So the packet filtering is prevents or allows access based on IP or MAC address. The MAC address or the IP. And the application filtering prevents or allows access by specific application types. And the URL filtering prevents or allows access to websites based on specific URLs and keywords. And for the device security, device security is all about the password and how you can track or how to set a strong password and how not to set a weak password. For example, a weak password is probably a word like a secret, simple word, secret. And example for a strong password is a combination of an integer and variables like B6, 7, combination of words and letters and numbers. So on how to make or create a password that is really strong is use a password length at at least 8 characters, preferably 10 or more characters. Longer password is a better password. Avoid passwords based on repetition or common dictionary words. Change password often if a password is unknowingly compromised. Don't write passwords down and leave them in obvious places. Yeah. Lastly, guys, troubleshooting. Troubleshooting is um, a skill that probably most of all networks or network technicians must have. You must always have the simple or complex combinations on how to troubleshoot a software or a hardware. Also, you should have the analyzation or on how you analyze the problem and determine the cause of the error before they can solve the network issue. For example, identify the problem, establish a theory, test the theory to determine the cause, establish a plan, verify full system functionality, and implement preventive measures and document findings, actions, and outcomes. And in troubleshooting, you should always verify and monitor your solution. Verifying and monitoring your solution is always checking your command prompt, typing ping, or how to trace the connection, how to show your commands, and how to show the IP interface because it notices the two interfaces configured and the use of IPv4 and IPv6 and addressing those two protocols, IPv4 and IPv6. And that is how you m- verify and monitor your solutions in a network. So that's it, guys, for our chapter 11, build a small network summary. Thank you.